in the event of an emergency, we're very proud of the way that we manage emergent events here at our laboratory, and we've been very successful over the few years that I've been here, 6 years now. Please exit the 2 doors in the back, and then we have emergency response personnel, and they'll lead you across the hall, the driveway to a muster area. And for those of us sitting here in the front, we'll exit through these 2 doors and then walk up the stairs, and we'll guide all of you to the appropriate muster area. So without further ado, introduce you to Mike Witherall, our director. Thank you.
Thanks. Hello, everybody, and welcome to Berkeley Lab, and especially welcome to this 2023 Enrico Fermi Presidential Award Ceremony. We're thrilled to be having it here today. All of us are so pleased to be able to host this event here in our site to celebrate and honor the scientists who really are the pinnacle of what we aspire to be here at the laboratory. They really are the best among us, and they serve as role models for all of us. So I want to give a special welcome to Darlene Hoffman, who's in the back, so thank you. And the photographs of historic figures in my office, Darlene is the only woman on that wall, who says something about where our lab was at that time. And for Gabor Somerjai, we have his family here today representing him. He couldn't be with us today. We're here to accept this award on his behalf. And I've really benefited from my conversations with Gabor during the time that I've been here. So congratulations. So thank you. This award recognizes Darlene and Gabor's remarkable achievements and their lifelong commitment to discovery science and inspiring the next generation of researchers and the people that they brought up through the system into their scientific careers. They exemplify our lab's longstanding legacy of scientific excellence. I'd also like to welcome members of the DOE's leadership team here today, including Director of the Office of Science, Azmarit Azafar-Berre, who's here in front of me. And Harry Kang, who's in the Office of Science Deputy Director for Science Programs. Let's see, and Paul Golan, who's head of our site office and our Berkeley site office manager. So I have many of the people I report to are here right now, and we haven't gotten to all of them yet. And I want to also welcome Cynthia Friend, who's president of the Kavli Foundation and chair of BSAC, the DOE's Advisory Committee for Basic Energy Sciences. Then for the University of California, we have to my other direct report is to President Michael Drake, who is with us today. So thank you so much for being here. And our UC System Provost, Catherine Newman, who's here. And from UC Berkeley, we have Carol Christ, the Chancellor. And Provost Ben Hermlin as well. So this is a very high-powered group. It's an honor also to have with us elected officials. We have who's talking to Berkeley Mayor Jesse Aragon. Where are you, Jesse? There he is. Oakland Mayor Sheng Tao. I don't think she was here. I'm not there. Let's see. We're also joined by staff members for Congresswoman Barbara Lee and Congressman Eric Swalwell. And I should say I have a couple of my my fellow lab directors are here as well. Kim Budil from Livermore, and Stephen Streifer from SLAC, and there's Stephen back there. So I have a lot of friends here today, and we're really pleased. It's such a grand experience that we're here for. So we also are hosting many people on Zoom today. This is actually as full as our auditorium has been for some time, so it's great to see you in person. But of course, we're actually connecting to a nationwide audience on this too. So I'd like to welcome all those people to Berkeley Lab, to this example of what we are at our best. And so with that, I'd like to introduce our Master of Ceremonies for this event, Dr. Azimrit Asifat.
Thank you, Mike. And thank you everybody for being here. Truly the best part of the job that I have right now is when we get to celebrate science and scientists. So I'm really honored to be here with you all to celebrate today's events. And I really want to thank the Berkeley Lab community for hosting today's event. This remarkable achievement on behalf of the two scientists, but also for the community of scientists that, as Mike stated, that they nurtured over the years, and the community that they've been part of. So really honored to be here on this major occasion. It's of course a pleasure to be back here at Berkeley, LBL. I'm a little biased because I spent a lot of time here as a grad student and postdoc, but still I think it's fair to say that is in one of the just amazing, remarkable places. Beautiful for sure. And especially on a day like this when we get to celebrate incredible scientists, it's quite a pleasure to be here. So figured I'd start by telling you a little bit about why LBL is such a special place, not just for me, but clearly for a lot of people, right? For me personally, LBL was my entry into the world of DOE. When I was really fortunate that when I was a graduate student just down the hill, I had a mentor up here. And so I spent a lot of time in her lab working with her up here at LBL, which not only just opened my world in terms of what is possible, the work that I was doing on the science, but also what it means to be part of the national labs, what the incredible community of scientists that exists in national labs, the resources that exist at the user facilities, which made my work incredibly special. And so it's been a wonderful journey for me, but now I'm in a, even before I took this job as director of the Office of Science, which of course I'm honored to be nominated and confirmed to by the White House, I'm a professor at UC Merced, another one of the UC campuses, as I was joking earlier with some of you. And I've been there for 14 years as a professor before I was nominated by President Biden for this role. And I'm so fortunate to be now in a position when I'm a professor, of course, to have my own students go through this journey, experience what it means to be part of the national lab system, experience what it means to take advantage of these incredible labs and facilities that we have out of the Office of Science that I'm very, very honored to lead right now. One of the most wonderful perks of my job, as I said, is not just that I get to visit our amazing national labs, all of them here that we talked about today, right? And of course, we steward from the Office of Science, for those of you who might be guests today, we steward 10 of the 17 DOE national labs, including Berkeley and SLAC. And it's, I get to be a cheerleader, then go out and learn about the amazing science that they do there, but also celebrate on days like today. But first, before you hear from me, actually, I'm honored to introduce you to my boss, U.S. Secretary of Energy, Jennifer Granholm, to give a brief remarks on the event. While the secretary regrets that she can't be here in person today, she wanted to make sure that she sends her message of congratulations. I would like to say that before you hear her words, she is an incredible, amazing leader for the department. She's an energetic, amazing champion for the Department of Energy and everything that we do in the department. Secretary Granholm can often be heard saying how the Department of Energy is the nation's solutions department. And I, of course, fully agree with that, but I'll amend that statement a little bit and say the Department of Energy is the solutions department. And for us at the Office of Science, all the solutions start with science. And so without further ado, please join me in welcoming Secretary of Energy, Jennifer Granholm.
Thank you, Dr. Berhe, and good afternoon, everyone. Welcome to this year's Fermi Awards ceremony. I want to thank Dr. Berhe's team and DOE's Office of Science for managing the Fermi Award program, as well as, of course, the folks at Lawrence Berkeley National Lab for hosting what I am certain will be a wonderful event. So So every year, the Department of Energy joins the White House in honoring the legacy of Enrico Fermi and in celebrating those who carry his torch today with their groundbreaking discoveries in science technology. Parts of Dr. Fermi's story may resonate with today's awardees. From an early age, he showed an extraordinary aptitude for math and science, which blossomed into a distinguished research career. In 1939, when war broke out in Europe, Dr. Fermi and his family fled, first to Sweden and then to the United States, where the scientific teaching community welcomed him with open arms. And then 5 years later, in a makeshift underground lab, Dr. Fermi built Chicago Pile 1, the world's first nuclear reactor. And then on December 2nd, 1942, at 3:53 p.m., his team recorded the very first self-sustaining nuclear chain reaction. In that moment, they unlocked the secret to controlling one of the most powerful energy sources on the planet. I'm actually sure that today's awardees might also remember the exact time and date of their discoveries. I'm sure they can remember the rush of excitement and the sense of awe as they wrapped their heads around what these findings could mean in their fields and for the world at large. We're privileged to work somewhere that helps make these moments possible every day. At DOE's 17 national labs, some of the world's most brilliant scientists and researchers are constantly doing things that have never been done in the course of human history. From producing the radioisotopes that revolutionized how we diagnose and treat cancer, to building the supercomputers that are demystifying the evolution of our universe, to creating the clean energy technologies that'll help us overcome climate change. Radical scientific breakthroughs make up the DNA of this department. They're fundamental to our success as a nation. And nothing gives us more pleasure than celebrating these accomplishments with the folks who achieved them. So today, it's my honor to congratulate the 2023 Fermi Presidential Award laureates, Dr. Darlene Hoffman for her discoveries to advance the field of nuclear and radiochemistry and her service to DOE's national security and environmental management missions, and Dr. Gabor Shamorii for his key contributions to our understandings of surface science and catalysis. And congratulations to their families. As I'm sure our awardees would agree, they could not have done this without you. So thank you all, congratulations, and have a wonderful event.
Next, I would like to welcome Dr. Arathi Prabhakar. Dr. Prabhakar is right now serving as the director of the White House Office of Science and Technology Policy, OSTP. Dr. Prabhakar is also the president's chief advisor for science and technology, a member of the president's cabinet, and co-chair of the President's Council of Advisors on Science and Technology. She's been a tremendous force for science and technology, a champion really, and a champion for innovation her entire life. I think many of you might know her. She is a trailblazer, another just incredible woman. She has served as the director of DARPA previously, the Defense Advanced Research Projects Agency, and she was the first female director of NIST, the National Institute of Standards and Technology, during the Clinton administration. Today, she's continuing to lead the charge on all things science and technology related across the federal enterprise during such a pivotal time. And it's really my honor to introduce and welcome Dr. Prabhakar today.
Hello from the White House, and congratulations to Dr. Darlene Hoffman and Dr. Gabor Shamorii. It's my great honor to represent the Biden-Harris administration today in recognizing their lifetimes of achievement. President Biden likes to say that America can be defined in a single word, possibilities, and that is exactly what we're celebrating here today. The inventive work of these awardees opened new frontiers in nuclear science and in surface chemistry. It greatly expanded the art of the possible, and it accelerated the pace of scientific progress to deliver long-lasting benefits to our world. Dr. Hoffman's career has been and continues to be nothing short of inspirational. As many people have noted before me, she was a pioneer in her field, the first person to discover a plutonium isotope in nature, and also the first woman in so many rooms and in so many labs. Truly impressive. Dr. Hoffman's foundational discoveries advanced the field of nuclear stability and radioactive decay, leading us to store radioactive materials much more safely. And she wasn't one to be confined to the laboratory. Dr. Hoffman led investigations at nuclear weapons test sites and nuclear waste facilities to prevent dangerous radioactive leaks from spilling into the surrounding environment. And Dr. Samarjai opened new paths in the field of surface chemistry and catalysis. He created new tools and techniques that reveal how chemicals react with one another. This is the foundation of our modern industrial processes. His notable discoveries have enabled innovations in chemical processes that are more efficient and materials that are less hazardous. Applying Dr. Samarjai's findings, we can now purify water, convert energy sources, and expand nanotechnology capabilities to improve people's lives. Our world is better because of Dr. Samarjai's brilliant work. Today, we honor two scientists who have spent hours and hours in the lab striving to do things that nobody else had done. They each have creativity to dream new things. They have the courage to fail until they succeed. They have the tenacity to bring their discoveries to life outside of the lab, and they have shared their many insights by mentoring hundreds of graduate students, postdocs, and fellow scientists. They inspire people of all ages to excel, and their foundational work provides a strong platform to build the next generation of American innovators. Their achievements illustrate the powerful idea that science, technology, and innovation give us the means to step beyond the limitations of today and to deliver a better tomorrow. To the awardees, thank you for dedicating your lives and your careers to such important endeavors.
Thank you to Secretary Granholm and Dr. Prabhakar for those really incredible words. And I'm going to restate that today we're honoring two incredibly distinguished scientists who've made significant and lasting contributions to science and society. The Enrico Fermi Presidential Award was established in 1956 as a memorial to the legacy of Enrico Fermi. It's one of the oldest and most prestigious science and technology honors bestowed by the US government. The Enrico Fermi Award is given to encourage excellence in research in energy science and technology benefiting humanity, to recognize scientists, engineers, and science policymakers who've given generously throughout their career to advance energy science and technology, and to inspire people of all ages to explore new scientific and technological horizons. Fermi Award laureates receive a citation that's signed by the President of the United States and the Secretary of Energy, a gold-plated medal bearing the likeness of Enrico Fermi, an honorarium of $100,000, which the recipients this year will share equally. The Office of Science is proud to administer this prestigious award on behalf of the White House. Today's laureates are joining a distinguished group of other Berkeley lab scientists, including Chuck Shunk and Andrew Sisler, former lab directors, received this award in 2014 and 2013, respectively. And Art Rosenfeld received it in 2005. Fermi awardees are nominated by their peers and selected based on results of a highly competitive selections process, including independent merit review. And while this award honors the exceptional technical achievements of our laureates, both recipients are also distinguished in their extraordinary records in mentorship and in service to their communities. Today, we get to add two more scientists to the prestigious ranks. Dr. Darlene Hoffman's achievements span, as you've heard, the disciplines of nuclear chemistry, actinide chemistry and separation science, and transactinide chemistry, radiochemistry, and very close to my heart, environmental chemistry. And Dr. Hoffman is here with her daughter, Maureen, son Daryl, and extended family. We are so pleased they could be here with us today. Please join me. And Dr. Gabor Samorjai is recognized for his seminal leadership in surface science and catalysis research. Dr. Samorjai is not able to join us, but his wife, Judy, who came with him to the US from Hungary many years ago, is here today, and she is joined by her son, John. Welcome to all of you. Huge congratulations to Dr. Hoffman and Dr. Samorjai for your incredible contributions to not only science, but also our future, which we will be hearing more about shortly. And so earlier I told you that I'm introducing my boss, who's of course my boss in my current job as the director of the Office of Science, Secretary Granholm. Now I have the honor of introducing my boss in my other job, my permanent job, when I'm not doing this job, when I'm not in this position. So I'd like to introduce Dr. Michael Drake, the president of the University of California, to the stage for remarks. Dr. Drake is the 21st president of the University of California. He oversees UC's world-renowned university system of 10 campuses, 5 medical centers, 3 nationally affiliated labs, including LBL, more than 280,000 students, and 230,000 faculty and staff. Welcome, Dr. Drake.
Thank you very much. Very nice to be here. I've heard that introduction before, and when I hear the number of students and faculty, it gives me a headache. But it's a great honor to be here and to be able to honor the work that's done here. I love coming to the lab. I have this age-old memory of growing up in Sacramento, driving to San Francisco and going by this part of I-80 and looking up on the hill and seeing those fascinating buildings where that incredible work was taking place. It was a mystery who was actually doing what in those places, but I knew it was magical, I knew it was scientific, and I knew it was a possibility. And I think that the University of California and the labs and our affiliation with the labs have been a source of inspiration to generations of people over all these many years. Wonderful to be able to take this moment to recognize a few of those people, 2 in particular, who've done so much to change our world and make it a better place. So privileged to be here today. And thank you, Dr. Berhe. I'm happy to be able to recognize Bobcats wherever I go, and you thanked your boss, who is another bear. So it's great to have us represented in Washington as well. Let me say that since 1931, the University of California has managed Lawrence Berkeley National Laboratory. This historic partnership between the U.S. Department of Energy has done so much to advance science and innovation for the benefit of our country and the planet. Our shared values are at the heart of this partnership: a deep respect for scientific discovery, a focus on fostering the next generation of research scientists, and a commitment to lowering our collective carbon footprint. I'm honored to be here today to celebrate 2 extraordinary scientists who embody these values and have done so much to contribute to the success of the lab and of the University of California. This year's Fermi Award laureates are wonderful examples of the synergy between the university and the Berkeley lab. Dr. Hoffman and Dr. Samorjai each hold appointments at both institutions, and their research brought together Berkeley faculty and lab scientists from multiple disciplines. They flourished within Berkeley Lab's unique user facilities, and talented UC Berkeley graduate students and postdocs supported the research groups and benefited from the collaboration. These award laureates made their marks in many memorable ways. Dr. Samorjai was instrumental in securing DOE funding for a new building at the lab. Dr. Hoffman made significant discoveries across the national lab system, with her work first at Oak Ridge, then Los Alamos, and finally here at Berkeley. Importantly, both laureates devoted much of their careers to nurturing the next generation of scientific leaders. They have each influenced and inspired countless people in their fields. even those driving by the buildings not knowing what they were doing. We are honored that the University of California is home to such extraordinary research scientists. Congratulations, Dr. Jamorjai and your family, and Dr. Hoffman and your family. Your legacy and the enduring partnership between the University of California and the national labs continue to inspire and transform science. Thank you.
Thank you, Dr. Drake. Now we will transition to the presentation of the Fermi Award Medal and citation signed by the President of the United States, Joe Biden, and the Secretary of Energy, Jennifer Granholm. First, we will recognize Dr. Darlene Hoffman with a short video produced by Berkeley Lab featuring her inspiring accomplishments.
Internationally recognized for her groundbreaking research on heavy elements, Darlene Hoffman has made extraordinary contributions to the field of nuclear chemistry. Her scientific leadership and service to the community helped to shape the field's direction, and her mentorship inspired generations of students. As an undergraduate at Iowa State College, Hoffman took Nellie Naylor's chemistry class. Naylor inspired Hoffman to undertake the academic trajectory that would lead to her remarkable career. At Los Alamos National Laboratory, she worked on projects in the field of nuclear chemistry. Then, it was believed that transuranium elements did not occur in nature. But in 1971, in what Glenn Seaborg termed an experimental tour de force, Hoffman became the first person in 60 years to find a primordial heavy element in nature, plutonium-244. Later, her discovery that atoms of fermium could split spontaneously became integral towards creating methods to inexpensively store nuclear waste away from the environment. Hoffman also developed medical applications of nuclear chemistry, especially for diagnosing and treating cancer. In 1984, Hoffman came to Berkeley Lab to lead the Heavy Element Nuclear and Radiochemistry group. She also began teaching in the chemistry department at UC Berkeley. Here, as at Los Alamos, she inspired generations of young women to pursue careers in this field. She also worked on several collaborations with teams at Lawrence Livermore National Laboratory. At Berkeley, Hoffman and colleagues spearheaded a renaissance in the one atom at a time study of heavy element chemistry. In a talk with Brady Heron in 2012, she described the process she and her team had to undertake.
We would irradiate samples in the cyclotron down there, and then take the sample out, from the radiation area, put it in a lead pig, put it in the car, and then drive all the way up here, hell-bent for breakfast, and bring it into our laboratories in the building right behind you. We wanted to look at things that had minute half-lives or multiple minutes. That was about as good as we could do with that method.
In 1994, Hoffman confirmed Al Ghiorso's earlier discovery of element 106, naming it after her colleague and mentor, Glenn Seaborg. Later, she led a team that made stunning discoveries at the frontiers of the periodic table.
All good experiments happen late at night when you're ready to quit. It's when you think you just can't go on and you do the little extra experiment or little extra thing that's necessary to pin it down. And I've found that many times.
Dr. Darlene C. Hoffman from Lawrence Berkeley National Laboratory and the University of California, Berkeley is recognized today for scientific discoveries advancing the field of nuclear and radiochemistry, for distinguished service to the department's missions in national security and nuclear waste management, and for sustained leadership in radiochemistry research and education. Please join me in a final applause for Dr. Hoffman. Next, we recognize Dr. Gabor Samarjai with a short video produced by Berkeley Lab featuring his remarkable achievements.
Gabor Samarjai is among the most cited chemists in the fields of surface chemistry and catalysis, and his work over 7 decades has led to improved understandings of important surface interactions, such as adhesion, lubrication, friction, and adsorption. In turn, these insights have contributed to significant advances in the pharmaceutical, agriculture, and automotive industries. Born and raised in Hungary, as a teenager, Gabor Samarjai was known more for his prowess on the basketball court than in science class. His father convinced him to enroll as a chemical engineering major at the Technical University in Budapest. In 1956, just before graduating, Samarjai fled his Soviet-controlled homeland in the mass exodus that followed the Hungarian Revolution. He eventually emigrated to the US, where he began graduate studies at UC Berkeley. Before he could start his research in the young field of surface science, Samarjai had to build his own instruments. He remembers that, quote, learning how to use the machine shop was essential, and the ability to pick the locked machine shop door on the weekends was a necessary requirement for the PhD. In 1964, Samarjai was offered a joint appointment at both UC Berkeley and Lawrence Berkeley National Laboratory, where he remained for the rest of his career. Back then, the traditional understanding of catalysis, how a substance increases the rate of a chemical reaction, was that reactions were controlled solely by discrete sites on the surface. But in one of his first discoveries, Samarjai overturned that assumption, finding that reactions strongly depend on the entire surface structure and on the arrangement of atoms on that surface. For the next 20 years, Samarjai and his multidisciplinary group, including his one-time postdoc, Michael Salmeron, built up an impressive repertoire of instruments and techniques, deepening scientific understanding of surface processes. In the 1980s, he began using surface analysis methods to investigate catalytic polymerization chemistry. His findings led to improvements in industrial catalytic processes and to consulting work with General Motors, Dow, and others. In the 2000s, nanoscience came to the fore. With Peidong Yang, Samarjai explored the properties and applications of nanomaterials for catalysis and energy-related processes. These contributions advanced a range of research, from energy storage to biomedical devices. His research has helped facilitate the synthesis of semiconductor materials, the development of hydrogen-powered electric vehicles, and the observation and study of natural processes such as the depletion of ozone in the stratosphere. Over the course of his career, Samarjai mentored over 400 students who went on to successful careers in academia and industry. He was well known for his uncanny ability to pinpoint exactly the heart of a problem. Samarjai's long-term vision of scientific progress in multiple directions was realized in advancements in a number of disciplines, as well as in industry, where it's estimated that 90% of all commercially produced chemical products involve catalysts.
I think one of the great advantages of being a scientist and an engineer, you can not only be a spectator, but also be a doer that has an impact on the future.
Dr. Gabor A. Samarjai from Lawrence Berkeley National Laboratory and the University of California, Berkeley is recognized today for seminal advances in molecular studies of surfaces through the use of single crystals, for the development of techniques for quantitative determinations of surface structure, and for establishing the molecular foundations of heterogeneous metal catalysis. Please join me in a round of applause for Dr. Samarjai.
Thank you, Talia, for the wonderful citations, and everybody, the team, for those wonderful videos that really demonstrated how incredible of a career that these both scientists have had. Once again, congratulations, Dr. Hoffman and Dr. Samarjai. You're truly an inspiration to all of us and a whole generation of scientists coming behind you. And you've had careers that have really demonstrated remarkable creativity, insight, and lasting impact. Everyone, please join me in recognizing today's Fermi Award laureates for their incredible contributions to science and the nation. Before we conclude today's proceedings, I would like to thank those who helped make today's event happen. I'd like to thank special thanks to Berkeley Lab for hosting this wonderful event on the campus today. It's wonderful to see so many of you join us in celebrating these outstanding laureates. I also want to thank the Department of Energy's Office of Science, Deputy Director for Science Programs, Dr. Harriet Kang, and her team for shepherding these awards from really beginning to this point. Thank you also to all for joining us and celebrating everybody that's here in person and in Zoom, in celebrating our distinguished Fermi Award laureates. And I hope we all feel inspired and ready to do more amazing science after this. I also hope today will inspire you to support or lead a nomination for the next Fermi Award. Nominations are now open, and they will and they will close on July 10. So please think about this. As for today, for those attending in person, please join us at the reception. Please exit through the door on this side of the auditorium. Please make sure on this side, because folks have other plans for the other one. There will be people directing you, as well as signage to the reception location. I'll ask that the laureates and their families, if you could please remain in the auditorium for a few group photos. Congratulations again to Dr. Darlene Hoffman and Dr. Gabor Samarjai for their 2023 Fermi Award, Presidential Awards. So really honored, everyone, that you're here with us. Thank you, everybody. Have a good day.